Good morning from NASA's Kennedy Space Center. You're looking live at Space Launch Complex 40 at Cape Canaveral Space Force Station, where SpaceX is getting ready to launch a Falcon 9 rocket carrying the European Space Agency's Euclid space telescope. We'll be bringing you live coverage as SpaceX counts down to a liftoff at 11:12 a.m. Eastern Time. That's 1512 UTC for our viewers around the world. I'm Stephen Young, and I'll be providing commentary from Spaceflight Now's News Bureau at the Kennedy Space Center press site. I'm joined by my colleague, Adam Bernstein, who will be operating the cameras this morning. If you'd like to support our coverage of the space program, please go ahead and hit the thumbs up button to like this stream. And if you haven't already, click the subscribe button so you'll get notifications. That way you won't miss any of our future launch coverage. You can also support our work financially by using the Super Chat feature or by becoming a member of our YouTube channel. We can't do these broadcasts without the support of our members and viewers, and we'd like to thank everyone who's made a contribution to help our coverage. We're expecting great weather this morning for the launch of the Euclid telescope. The 45th Weather Squadron at Patrick Space Force Base issued a forecast with only a 10% chance that the weather could violate the rules as far as liftoff conditions today. The only possibility of a weather problem would be a violation of the cumulus cloud rule. As you can see from this view, it's a hot and steamy day at the spaceport on Florida's Space Coast. If you haven't done so already, please hit the thumbs up or the like button. That really helps us bring in a larger audience for our coverage. This morning's launch is taking place from Space Launch Complex 40 at Cape Canaveral Space Force Station. The pad was originally constructed in the 1960s for the U.S. Air Force's Titan rocket program. It's located at the north end of Cape Canaveral Space Force Station, right on the border with NASA's Kennedy Space Center. There were multiple launches from Pad 40 for the U.S. Department of Defense over 4 decades. This pad also launched NASA's Cassini-Huygens mission on its 7-year voyage to Saturn. The Titan family of rockets flew a total of 55 times from this launch pad. After the last flight of the Titan IV rocket in 2005, the Air Force handed over Pad 40 to SpaceX. A lease was signed in 2007, and the Titan launch tower, a mobile service structure, was demolished. The SpaceX Falcon 9 flew from Pad 40 on its inaugural launch on June 4th, 2010. Work is now underway at Pad 40 to build an access tower for SpaceX's Dragon spacecraft, so cargo and crew missions to the space station can be launched from there. We're at T-minus 1 hour and counting. It's a little over 20 minutes away from the point in the countdown where the launch director will give a go for the start of propellant load for this morning's launch. SpaceX is running the countdown from its Launch and Landing Control Center just outside the south gate of Cape Canaveral Space Force Station. The launch team is also supported by control rooms at SpaceX's headquarters in Hawthorne, California. At this point, the chief engineer should have already conducted a technical poll of his team. In late May, we had an opportunity to visit the Euclid telescope inside a clean room at Astrotech, a satellite processing company in Titusville, just outside the gates of the Kennedy Space Center. We spoke with Giuseppe Racca, Euclid's project manager, about the science mission of the Euclid telescope.
Euclid that we see here in these facilities of Astrotech near Cape Canaveral is a cosmology mission, and the target, the objective is to study the dark universe, as called. We know that the universe is made primarily of stuff that cannot be seen. Let's say 95% is made of dark energy and dark matter together, and we are only about 5% of all what exists, let's say, is made of normal matter. Euclid will really target the dark energy and dark matter. The way to do it, of course, since cosmology is a matter of the entire universe, so you need to really make observation of a big part of the sky. So, and that's one of the main features of Euclid is indeed that it can make observation of a very large part of the sky, which is actually about 36% of the full sky. Why not everything? Is because we are in our own galaxy, the Milky Way, and while in the Milky Way we cannot observe the sky, the extragalactic sky properly, because there is a lot of gas and dust inside our own galaxy. So we can only look at the north and south of our own galaxy, and that makes up nearly about 36%, 15,000 square degrees of sky. So basically we look at all what is observable from our planet. And of course, we cannot observe dark energy, neither dark matter, because the fact that they are dark is because they do not emit and do not absorb radiation, and therefore you cannot observe it. But we can observe all the rest. We can observe all the stars or the galaxies outside our own galaxy, and we can really make an inventory of and a map of all the distribution of matter. By several techniques, by this distribution of matter, we can also infer what is the distribution of dark matter, because dark matter has a gravitational pull. So then by looking at how the normal matter is distributed, you can infer how much dark matter is in there. And that we have special techniques, which is called gravitational weak lensing to do this. Also by the same observation and observing the distribution of galaxies not only at our time, but also going back in time for 10 billion years, we can also see what is the evolution of dark energy during the last 10 billion years. Because dark energy, contrary to the other matter, it tends to make the universe expand in an accelerated way. And by looking at that at different time of this evolution, we can really characterize what dark energy is. Let's say if it is constant of the vacuum, as a certain theory says, or if it is, let's say, just peculiarity of gravity. Let's say like dark energy sometimes is called the cosmological constant, and which is part of general relativity equations that shows that with a certain constant you obtain the type of evolution that we see. And this thing needs to be proved. It's one assumption, and one of the experiments, one of the observations that we make with Euclid is to distinguish indeed a possibility of having a different behavior of gravity from general relativity to the existence of a new energy, which is really dark energy. So it's all yeah. Let's say the objective of Euclid is really to make big progress in this area, and possibly also discover that what we think today may even not be true at all. But that's really something that will come out after the observations.
That was Giuseppe Racca, the European Space Agency's project manager for the Euclid Space Telescope. We spoke to him on May 31st in the clean room with the Euclid telescope right there behind him. T-minus 50 minutes and counting. As far as we know, everything is proceeding smoothly towards this morning's liftoff of the Falcon 9 rocket from Pad 40 at Cape Canaveral. Liftoff is set for 11:12 a.m. Eastern Time. The launch director will be conducting a poll in the next 10 to 15 minutes. Let's take a look at the countdown timeline for today's Euclid mission. At T-minus 38 minutes, we should hear the result of the go, no-go poll from the launch director. If the go for launch is given, propellant load will start at T-minus 35 minutes. Kerosene will be loaded on the first and second stages of the Falcon 9 rocket. Also, liquid oxygen will be pumped aboard the first stage. Shortly thereafter, we should start to see some signs of venting and vapors at the launch pad. At T-minus 16 seconds, it's the turn of the liquid oxygen to start flowing into the second stage. Prior to this, we'll see the so-called big vent from the strongback as the feed lines on that structure are chilled down. At T-minus 7 minutes, the chill down of the 9 Merlin engines will get underway. This involves flowing a small amount of liquid oxygen through the plumbing and turbo pumps. This will protect those engines from the risk of thermal shock and damage during the startup sequence. About 6 minutes prior to launch, the first stage kerosene tank should be full, and then at about T-minus 4.5 minutes, we'll see the strongback structure at the launch pad start to retract away from the Falcon 9 rocket. It will recline to an angle of about 1.5 degrees, leaning back, and it will stay there until liftoff. And then at the moment of liftoff, the strongback will fall away in a more rapid fashion to clear the way for the Falcon 9 to lift off the pad. At about 2 minutes, liquid oxygen loading should be complete. At this point, the Falcon 9 will be fully loaded with 1 million pounds of propellants. And then in the final 60 seconds, the control of the countdown will be handed over from the ground sequencer to the Falcon 9's onboard flight computers. The propellant tanks will be brought up to flight pressure. The SpaceX launch director will then give their final go for liftoff. The engine ignition command will be issued at T-minus 3 seconds. And if all 9 engines ignite and are healthy, the flight computer will command hold-down clamps to release the Falcon 9, and the rocket will lift off.
A reminder, step 57.68 is open. Propellant load and launch go no-go pull. Looking for a ground station.
And we're now receiving audio from SpaceX's launch control. As you just heard, the launch director has started the poll for the go to begin propellant load. The launch team is based at the SpaceX Launch and Landing Control Center, which is about 10 miles south of the launch pad near Cape Canaveral. Inside that control center, engineers will be tracking the health of the Falcon 9 rocket, ground facilities, and the Euclid spacecraft. They will also be receiving updates from the 45th Weather Squadron. This poll takes place electronically. The launch team uses a mouse click to confirm they are go. Just a reminder, if you haven't done so already, please hit the thumbs up button to like our stream. We want to get as many people watching this launch, and that really helps us out. We're now at T-minus 42 minutes and counting.
Propellant load pull is complete. We are go for propellant load and launch.
And there you heard it. The launch director has confirmed that the launch team is go for launch. They've completed the poll, and they will proceed with loading propellants aboard the Falcon 9 for the launch of Euclid planned for 11:12 this morning. The start of propellant load will begin at T-minus 35 minutes.
vehicle tanks are venting for the start of propellant load.
This is LD briefing the abort instructions. For non-urgent no-go conditions, brief the CE or LD and they will approve aborting the countdown. For urgent issues affecting the safety of the operation, operator shall call hold on the countdown net. Launch control will abort the auto sequence immediately and proceed into launch abort. At T-minus 10 seconds, launch control will be hands-off, relying on automated abort criteria for the remainder of the count.
The launch auto sequence has started.
And there we have confirmation from SpaceX that propellant load has begun at pad 40. Let's take a closer look at the Falcon 9 vehicle. The bottom two-thirds of the rocket is the first stage. Today's first stage booster has only flown once before on the Axiom 2 mission earlier this year. At the base of the first stage are 9 Merlin engines, which burn rocket-grade kerosene and liquid oxygen to produce 1.7 million pounds of thrust. Around the engine compartments are the black carbon fiber landing legs that will be used to land the first stage on the drone ship. Above the first stage is the interstage. This is a composite structure consisting of an aluminum honeycomb core surrounded by carbon fiber. In the inset image, you can see the deployable hypersonic grid fins. These are titanium winglets that provide stability and steering for the Falcon 9 as it falls through the atmosphere and heads towards a landing on the drone ship. At the top of the first stage are 3 mechanical latches that attach it to the second stage. At first stage main engine cutoff, high pressure helium is used to release those latches, and 4 pneumatic pushers ensure there is a clean separation. The second stage engine nozzle is safely housed inside the interstage adapter until stage separation. The second stage is powered by a single modified Merlin engine called the Merlin Vacuum Engine, or MVAC. It is equipped with a large nozzle optimized for burns in the vacuum of space. It produces more than 200,000 pounds of thrust. It will be fired twice on today's flight to place the Euclid satellite on course for the Lagrange point, where it will conduct its observations. The MVAC engine burns the same propellant mix, kerosene and liquid oxygen as the first stage. At the very top of the rocket is the payload fairing containing the Euclid Space Telescope. The payload fairing is made of a carbon composite material and is 13.1 meters or 43 feet tall and 5.2 meters or 17.1 feet in diameter. Now less than 30 minutes to the launch of the Falcon 9 and the Euclid telescope. It's a very hot and humid day here at the Kennedy Space Center. Lots of heat waves in our video, but we should hopefully start to see some vapors. Maybe they're just visible between the first stage and the strongback structure out at the launch pad. It's very hard to see with the conditions the way they are today, but I think I can just make that out. The vapors are created by the hot, humid air coming into contact with the fuselage of the first stage, which is being filled with the super chilled liquid oxygen propellant. One other process that's underway during the countdown is the loading of cryogenic helium into pressure vessels on the first stage. That helium is used to pressurize the propellant tanks during flight. Euclid was originally intended to be launched on a Russian Soyuz rocket from the European spaceport in French Guiana near Kourou. However, when the invasion of Ukraine by Russia occurred last year, the European Space Agency had to find a different rocket for this mission. It was a rapid process, as Giuseppe Racca explained to us when we spoke to him in the clean room.
1 year ago, roughly, after the war, let's say the invasion of Russia in Ukraine, and after, let's say, it was really lost any hope that we could reuse Soyuz because there was no way of getting the cooperation back on track. It's about 1 year ago, let's say maybe a little bit more than 1 year ago, not much more. And at that point, we started looking around what other launcher can we use, because at the same time, Ariane 6, that it was our backup launcher already, was not ready and had delays. So then we had to be looking around to accommodate a completely already built spacecraft on another launcher. And this is not really an easy task because, let's say, typically you design a spacecraft for a particular launcher or maybe two launchers, but you don't design a spacecraft for a theoretical launcher. So going back and finding, with talking to SpaceX, actually 1 year ago, let's say we started the first discussion feasibility study with SpaceX on 1st of July, so not even 1 year yet. And with them, we saw immediately that Falcon 9 could be used. Was not really completely straightforward because Falcon 9 is a bigger launcher than Soyuz, and is also a little bit more, I would know how to call it, a bit sturdier launcher. So then the environment there, the mechanical environment, the vibration environment, is somehow a little bit more demanding than Soyuz. So we had to do a lot of work. Industry did a lot of work to look at all the various parts of in whether everything could be tolerated in the new environment. And in the end, there were many other things. The trajectory itself, leaving from Florida, is not the same as going to L2 from French Guiana. I mean, it's not a huge difference, but still, it's a difference. You need to design a trajectory that allows you to do that. And let's say, lucky enough, everything went well. And so then near 1 year later than that, we are ready to launch.
That was Giuseppe Racca, the ESA project manager for the Euclid mission, explaining how the Euclid telescope was moved from the Russian Soyuz rocket to the SpaceX Falcon 9. A process that started a year ago today. If you're just joining us, you're looking live at Launchpad 40 at Cape Canaveral Space Force Station. A Falcon 9 is standing on the pad, being fueled for launch at 11:12 a.m. this morning, carrying the European Space Agency's Euclid telescope. The Falcon 9 stands 70 meters tall, or 229 feet tall, on the launch pad. We're coming up on the so-called big vent from the strongback at the launch pad. This is where the pipes that provide fuel for the Falcon 9 second stage are purged and chilled to begin that loading process of liquid oxygen aboard the first stage. We should see, aboard the second stage. We should see quite a dramatic plume from the vehicle as that process begins.
Stage 2 RP1 load is complete.
And there we heard that stage 2 is now fully loaded with its rocket grade kerosene. The big vent is now underway at the launch pad. Once again, that's the chill down of the propellant lines that run up the strongback structure alongside the vehicle. That process chills down the lines and ensures that there's no air and any other substances that might get drawn into the second stage of the vehicle when that fueling process continues with the liquid oxygen load of the second stage. When this process of purging the strongback is concluded, we will hear the call from SpaceX that liquid oxygen loading has begun on the second stage. We're coming up on T-minus 18 minutes and counting. As you can see and perhaps hear, the winds are quite breezy here at the Kennedy Space Center. However, the last forecast we saw from the 45th Weather Squadron at Patrick Space Force Base indicated there was a 90% chance of acceptable conditions for launch today.
Stage 2 LOX load has started.
And then we have confirmation from the SpaceX launch team that The loading of liquid oxygen aboard the second stage of the Falcon 9 is now getting underway. We're also getting some video from SpaceX via NASA and the European Space Agency. We'll bring you some of those close-up launchpad shots as we get them. You'll see from the 2 clocks on the screen that the SpaceX video comes with a little bit of a delay. The clock in the top right is the range clock here at Cape Canaveral and is the accurate T-minus time. When we visited the clean room at Astrotech, we got a tour of the spacecraft from Giuseppe Racca, the Euclid project manager, and I'm going to play that video now.
Okay, we see here Euclid in his standing in vertical position, and we see on this side the cover covers the sun shield with the solar array. Let's say without this cover you would see the nice solar panels which produce the power for the spacecraft. We see also here the high gain antenna that once in space it will be deployed in order to be able to follow the Earth all the time. Other antennas are also covered because of the tests which are being made. And we see the red part are hydrogen thrusters. They are just covers that will be removed before flight. And they are hydrogen thrusters which are used to desaturate the reaction wheels and to position the spacecraft in correcting the spacecraft orbit. Instead, the white covers here cover another type of thrusters, which are the micropropulsion thrusters, the nitrogen micropropulsion thrusters. These are very minute correction that is done while we make observations. While we make observation, nothing can move, the antenna cannot move, the reaction wheels cannot move, but we have these thrusters which maintain the position of the telescope, guided by guiding stars which are actually directly being imaged by the telescope itself. We see here this funny shaped radiator is the radiator of the VIS instrument, the visible instrument, which is a smaller one because the visible instruments works at higher temperature than the near infrared instrument, which is here with the white big radiator, which is needed because the detectors must be maintained at about 100 K, so minus 173 degrees C. And this part is, let's say, the night part against the sun. The sun is on the other side, so it's all black to make radiation, let's say, radiating and cooling the internal parts. And on this side as well is also same radiators, black radiators, which are also necessary to cool down the various equipment which are inside the the spacecraft and the various equipment which are used for many subsystems and to provide power, provide attitude control and everything to the spacecraft. One peculiarity of this spacecraft is that it must be very clean, because every particle that is deposited inside the telescope could scatter lights and make disturbing it very much. And we are very happy to be in the facility here of Astrotech, because they are very clean facilities. And we have particularly chosen to be here because we wanted to have a very clean facility. And we are making samples all the time, and we see that it's really very clean. And that's a very important aspect of this mission. In this moment, the telescope is still covered. So then the cleanliness, we can be here dressed like that. But as soon as we will remove the telescope cover, we will not be able to be here. Only 2 people could be around the spacecraft, and they will have to be completely covered, because the cleanliness requirements will be enhanced much more.
Once again, that was Giuseppe Racca, the Euclid project manager, speaking to us in May inside the clean room where Euclid was being prepared for launch. We're now less than 10 minutes away from liftoff of the Falcon 9 from Pad 40. The next major step will be the chill down of the 9 Merlin engines at the base of the first stage of the Falcon 9. Let's take a look at the trajectory of the Falcon 9 today. It's heading due east from Cape Canaveral. It's heading into an orbit to reach the Lagrange point, the L2 point, where the Euclid telescope will be stationed to perform its scientific work. The first stage will land on the drone ship, a Shortfall of Gravitas. This is the latest and most modern drone ship that SpaceX operates in its fleet. It's about the size of a football field, and the first stage of the Falcon 9 will land on that drone ship in the Atlantic Ocean.
Spacecraft is on internal power.
That call from SpaceX's mission control indicates that the Euclid spacecraft has switched from ground power to its onboard batteries. It will start recharging those batteries when it reaches orbit and its solar panels are exposed to space. T-minus 7 minutes.
Engine chill has started.
And there we have confirmation from the launch team that engine chill is started. A small amount of liquid oxygen will be run through the engine systems to chill down those pipes and pumps to make sure that at ignition they are conditioned for launch and won't experience any thermal shock as those super cold propellants start entering the system.
Stage 1 RP1 load is complete.
We're at T-minus 6 minutes. We just heard confirmation that the loading of RP1 on the first stage is now complete. T-minus 5 minutes and counting. Everything's looking good so far for the launch at 11:12 a.m. Eastern Time.
Vehicle tanks are pressing for strongback retract.
And that call indicates that the tanks are being pressurized ahead of the retraction of the strongback. By pressurizing the tanks, that makes the vehicle a little more rigid as the arms that have held the vehicle in place at the launch pad are retracted at the top of the strongback structure. That structure will be retracted to an angle of about 1.5 degrees.
Strongback retract has started.
And confirmation from SpaceX that that retract operation is underway. Let's take a look at a close-up view from SpaceX's cameras at the launch pad. This camera on one of the 4 Lightning towers looking at the vehicle. You can see those arms are now opening up. And the structure will then begin to move away from the vehicle. It's controlled by hydraulic pistons at the base of the structure. And you can see in our camera view that that gap between the rocket and the strongback is opening up now. The strongback will move further away at liftoff. T-minus 3 minutes and counting.
Stage 1 LOX load is complete.
We have confirmation that the liquid oxygen has been fully loaded aboard the first stage. Still loading oxygen aboard the second stage. The flight termination system, an autonomous system, is being armed. T-minus 2 minutes. 2 minutes until the launch of the Falcon 9 with the European Space Agency's Euclid telescope. If you haven't done so already, please hit the like button on our stream. It really helps us out.
Stage 2 LOX load is complete.
And there we have confirmation that Stage 2 is now fully loaded with liquid oxygen. That means the Falcon 9 has about 1 million pounds of propellants aboard. And the venting we're seeing is the purging of the strongback propellant lines prior to launch. We're approaching the final minute of the countdown. T-minus 1 minute, the Falcon 9's onboard computers will take control of the flight. Stage 1 and 2 will pressurize shortly. We'll also have some steering checks of the first stage. Now let's
Falcon 9 is in startup.
And then we have confirmation the computers have taken over. We're waiting for the launch director's final go for launch. Everything on track so far.
LD, go for launch.
And there we have it, the launch director's final go for launch. In the final seconds of the countdown, thousands of gallons of water will be dumped onto the launch pad. Engine ignition will start at about 3 seconds. Ten, 9, 8, 7, 6, 5, 4, 3, 2, engine ignition and liftoff. Liftoff of the Falcon 9 carrying the Euclid Space Telescope. SpaceX reports the propulsion is nominal. Let's listen in to the roar of the Falcon 9 engines. Engines should be throttling down now as the rocket approaches the period of maximum dynamic pressure. Falcon 9 is now traveling faster than the speed of sound. That plume you're seeing is the shock waves created by the rocket as it soars skyward. Incredible roar of the engines of the 9 Merlin engines on the first stage. Getting some onboard camera views from SpaceX, now a minute and a half into flight. Got less than a minute left in the burn of the first stage. Chill down of the second stage engine has begun. Engine cutoff now about 30 seconds away. Falcon 9 continuing downrange. Coming up on stage separation. Looks like we've had stage separation.
Main engine cutoff. Stage separation confirmed.
We're now looking at an onboard camera showing that separation.
MVAC ignition.
The ignition of the MVAC engine on the second stage. On the left side of your screen, you're seeing the Falcon 9 first stage booster.
Both vehicles are following nominal trajectories.
Its titanium grid fins. These grid fins will help steer it towards the drone ship, a short fall of gravitas in the ocean. Meanwhile, on the right side, the MVAC engine of the second stage is glowing red hot as it propels the Euclid telescope into space. In this shot from SpaceX, I believe we're seeing the first stage actually above the second stage. The first stage is continuing to climb as its forward velocity is still propelling it higher. Earth's gravity will eventually get its grip back on the Falcon 9 first stage, and we'll start to see that altitude on the rocket drop. The Falcon 9 second stage, meanwhile, is now traveling at more than 10,000 kilometers an hour at an altitude of 130 kilometers. Beautiful views on the left-hand side of your screen of the first stage, now at 120 kilometers. Still creeping up in altitude. You can see the velocity is slowing. Meanwhile, everything going as planned with the second stage. The altitude has now started to drop. The Falcon 9 is starting to fall back. Second stage is now relaying data through the Bermuda tracking station.
Both vehicles continue to follow nominal trajectories.
You'll see the velocity start to pick up on the first stage as it falls back to Earth, now at 113 kilometers. Meanwhile, the Falcon 9 second stage continues to accelerate, 13,500 kilometers per hour. Falcon 9 first stage is now below 100 kilometers as it starts to enter the denser atmosphere. It will perform an entry burn to slow its return and avoid the friction of the falling through the atmosphere from overheating the rocket. That first stage entry burn is coming up shortly.
Stage 1 FTS has safed.
Yeah, we have ignition. This burn starts with 3 of the Merlin engines. You can see the speed gauge is now dropping as the rocket slams on the brakes as it falls like a dart from the sky. The second stage now traveling at over 21,000 kilometers per hour. Meanwhile, the first stage descending rapidly.
Stage 2 FTS is safed.
Now
Stage
below
2 terminal
15
guidance.
kilometers. And once again, on the left side of the screen, you're seeing a camera on the first stage of the Falcon 9 as it falls back towards the drone ship, a shortfall of gravitas, stationed in the Atlantic Ocean. We'll see the cutoff of the second stage, the first cutoff. Another burn is planned to place the Euclid telescope on course for the L2 point. Appears we've had second stage cutoff. You can now see the ocean coming into view. And the drone ship, a shortfall of gravitas. Landing burn is underway. Landing leg deploy.
Signal, Cape.
And
Nominal orbit insertion.
touchdown. Touchdown of the first stage of the Falcon 9. We've also had confirmation that the upper stage has reached its nominal orbit. That's good news for the Euclid spacecraft, which will now coast for a short while before a burn that will take it away from Earth to the Lagrange point. This orbit track shows the second stage of the Falcon 9 continuing its climb. And we just heard that it's now passed out of range of the tracking station on Bermuda. The tracking map also shows the first stage on its position in the Atlantic Ocean on the drone ship. The Euclid telescope has a primary mirror about half the size of the Hubble Space Telescopes, or about 18% of the James Webb Space Telescope. It's more of a wide-angled lens than the telephoto lens that we think of with other space telescopes. When we spoke to Giuseppe Rocco, he compared the Euclid telescope with the Hubble Space Telescope.
Let's say when you want to make a cosmological study, you need to observe a lot of the universe. It's not enough to observe very well, very nicely. For example, Hubble Space Telescope or James Webb Telescope, they are both exceptionally good telescopes which are designed to observe particular features of the universe. Let's say for example, JWST, it observes very back in time, let's say at the very origin of the star formation. And Hubble observes in the visible with incredibly good details and resolution. But they observe a very small part of the sky. Instead, Euclid observes the full universe, the full observable universe. And this is the peculiarity. And to do that in a short time, because we do that in 6 years, you need to have a particular construction. The telescope must be really with a particular design and particular realization as well, which allows you to have perfect observations with very wide angle, and therefore you can do that in a relatively short time. To compare, Hubble Space Telescope has a much narrower field, and to Hubble to do the job of Euclid, it would take hundreds of years.
Once again, that was Giuseppe Racca, the program manager for the European Space Agency. We're now a little over 14 minutes into the flight of the Falcon 9 carrying the Euclid Space Telescope.
Acquisition of signal, Brazil.
And back ignition.
And there we have ignition of the second stage. This is the second burn. This is the burn that will propel Euclid towards the Lagrange 2 point, which is located 1.5 million kilometers behind the Earth as viewed from the Sun. It's a good spot for space observatories to work from. Velocity of the second stage now over 35,000 kilometers per hour.
And back shutdown.
There we have confirmation of the shutdown of the Merlin vacuum engine on the second stage.
Nominal orbit insertion.
And it sounds like the Falcon 9 second stage is right on the money. SpaceX calling out a nominal orbit insertion. There's quite a long coast period ahead now. Euclid will be released from the Falcon 9 second stage about 41 minutes after launch. Flight controllers at the European Space Agency's Space Operations Center in Darmstadt, Germany, are expecting to receive the first signal from Euclid following separation at about T plus 45 minutes. That signal should be relayed via the European Space Agency's ground station in Australia. We'll stay live through the separation of the Euclid spacecraft. The second stage of the Falcon 9 carrying Euclid is now about midway across the Atlantic Ocean between South America and Africa.
Detected loss of signal, Brazil. Acquisition of signal, Gabon. Acquisition of signal, HBK, 26 meter.
It's now been 30 minutes since the launch of the Falcon 9 carrying the Euclid Space Telescope. The second stage of the Falcon 9 with the Euclid telescope attached is now approaching the west coast of Africa. You can see in this tracking map view that the spacecraft's orbit is heading away from Earth. It's heading for the Lagrange point 2. That's 1.5 million kilometers from Earth. Separation of Euclid from the second stage should occur in a little over 10 minutes. Now less than 5 minutes until the separation of the Euclid satellite. Now about 3 minutes to the deployment of the Euclid Space Telescope. After Euclid is released from the Falcon 9 second stage, it will be a few minutes before we get confirmation that the European Space Agency is receiving telemetry from the spacecraft via the New Norcia ground station in Australia. Now getting a view of the Euclid telescope in the darkness there atop the second stage of the Falcon 9 rocket. This camera is mounted to the second stage looking upwards. About a minute now to separation. And although ESA expects to receive communications with Euclid about 45 minutes after launch, they won't be overly concerned if they do not pick up that signal immediately. It could take 15 minutes or so before they do get confirmation that all is well. Less than 30 seconds now to separation.
Euclid spacecraft separation confirmed.
We just got verbal confirmation, and there's the video. Euclid is separated from the second stage of the Falcon 9. It's now drifting away, flying 3. It's heading towards the Lagrange point 2, 1.5 million miles from Earth, on the opposite side of Earth from the Sun. This is also the location for the James Webb Space Telescope. The Euclid spacecraft catching the sunlight there, and some particles floating around. It appears that SpaceX has concluded its broadcast of today's launch. We'll stay on the air as we await confirmation from the European Space Agency that the signal has been acquired from the Euclid spacecraft. Here's a look at launch pad 40 at Cape Canaveral, the empty launch pad where Euclid blasted off at 11:12 a.m. We're now getting video from the European Space Operations Center in Darmstadt, Germany. This is where controllers will check out the Euclid spacecraft. We'll listen in to the audio from the European Space Agency. This is the control room that has been used for all major European space missions, including the Rosetta mission to
all positions ready. We have received the post-separation OPM from SpaceX.
Sounds like that was a call that they have just received confirmation from SpaceX that deployment occurred. Still waiting for that signal. Presumably we'll see a spike on that chart on one of the front screens there. It's the Flight Operations Director at ESOC. ESOC is the abbreviation for the European Space Operations Center.
Hey, so all positions ready. We have a signal from Euclid in space.
Yes.
And you can see by the reaction, it received the signal from Euclid. You also heard the call over the loops there. That's good news for the mission. Good sign that all is going well so far. Well, so with the acquisition of that signal via the new Norsha ground station in Australia, we are going to conclude our live coverage of today's Falcon 9 launch of the Euclid Space Telescope. This mission will hopefully shed light on the dark universe. Astronomers are only able to identify about less than 5% of the universe. The rest of the 95% is thought to be dark energy and dark matter. And the Euclid mission will create a 3D map of the universe that will hopefully allow scientists to confirm or refute the theories about dark energy and dark matter. So with that, I'd like to thank Adam Bernstein for operating the cameras today in the hot Florida conditions that we are experiencing right now. And we'll look forward to seeing you again for the next launch from Cape Canaveral later this week.